There it is. Now the volume's on, yeah. So it's recording whatever's on the screen and whatever we say at the same time. So whoever's watching this tonight, we can even add an additional mic here so that additional mic for questions, or if Vasily wants to add commentary during it.
That's wrong.
So we could hang it from the middle so all comments go on there, and everything could be in there. So you can pass the mic around as we go.
Well, I touch peanut butter, so I don't give other people allergic reaction.
So this is
Recording right now?
all right.
We're recording right now. Is it on?
Here, Liam will have it for a bit. Okay, so what we're doing
Hello.
today is adding and
Can you hear me?
subtracting vectors.
Is this on?
Yeah, it's on.
Yeah?
Yeah.
Oh,
so-
okay.
Yeah, just put, and then we have questions. Ask good questions or bad questions or whatever you like, and it'll be on there tonight. And they're wondering, when is this class going to get started? Because they've now been watching for 30 seconds a minute, and we've done nothing. Wow. So here we have a bunch of vectors. So this vector u goes from A to B, the vector v goes from B to C, and the vector w goes from A to C. Now, with vectors, we're not necessarily concerned about how long it gets to a certain place, as long as you get to the same place. So we could say that going from A to C is the same as going from A to B and then B to C. Yeah, it might take longer, but you still end up at the same place. So that's what vector addition and subtraction is about, is saying that the vector w is equal to the vector u plus the vector v. And when you add vectors, you add what's called the head of a vector, which is that part with the arrowhead, and the tail, which doesn't have the arrowhead, and you put those together. So you can see that there we started here, and we go to this vector, which would go to B, and then we start here and go to C, and that's the same as starting from here and ending there anyways. Now, this vector w, which is the result of adding A and B, we call that the resultant. Very nice. And then for adding, if A to B is the vector u, we saw this before, if you go in the opposite direction, you just make that negative u. So it's the same length, but just in the opposite direction. So here we've got A is 2i minus j, and B is negative I plus 3j. Remember that what goes with the i's are like what goes with your x values, and what goes with j is what goes with y values. So the vector A, if we pick any point to start with, say there, I'm going 2 in the x direction and 1 down. This would be my vector A. You can start wherever you want. That's the nice thing about vectors.
Nice.
Then you started at a wrong spot. Then you start again somewhere else if you run out of room. You're being recorded right now. This is going on YouTube.
You're live.
Should we pass her the mic?
Yeah. You want it? I was recording me chewing my apples just so that they would know that I was eating.
Nice. So then B here, we got, you just want to survive. So if we start from here and we go with B, and I'll draw it in blue here, if B is down 1 and 3 up, or sorry, left 1, so I'm going to go left 1 and up 3.
3 up.
That would be B.
So J is in the Y?
The J is in the Y, and the I is in the X. And so A plus B would mean we started here and we ended here. And so if we look at the diagram for A plus B, we are now going 1 to the right and 2 up. So this is going to equal 1 to the right, I. And remember, we underline our vectors, or bold them, but it's pretty hard to bold them, so we underline them. 1 to the right and 2 up would look like this. Now look at the expressions. Can you figure out a way that we're going to be able to do this without having to draw the picture every time? Just add and subtract A and B. I would have, because my A was 2I minus j, and my B was negative I plus 3j. And if you think of like terms, what's 2I minus an I? I. And negative j plus 3j's?
2J.
2j's. So we could draw it out, or we could just do the math. Because it doesn't matter where on the graph that you start with, if that's what happens, that's what you're going to end up with.
Call me 3J.
Now b minus a, what I can do is I can take this vector b and draw it again. So there's my vector b. Now minus a would be the same as a, but in the opposite direction. So now, instead of going same direction, opposite direction, but same length and same magnitude. So it's still going to look that way, but now minus a will go in the opposite direction. This time we started here. We started here and we ended here. So we've gone 2 to the left and 1 up. Now as far as the math goes and writing it out to begin with, if I write b, which was minus I plus 3j, and I subtract a, which is 2I minus j, ooh, and we got the negative outside of brackets here. It's going back to grade 9 math. Got to distribute that. So you're going to have negative I minus 2I. Did I draw something wrong? Maybe. We'll look at it in a bit. That'll give me minus 3i's, right? And plus 4j's. What did I do wrong?
Well.
Now this is being recorded and we're going to put this on YouTube. Yes. I can push pause. See, I can push pause like this, record. So it's been 25 minutes, and I couldn't figure out what it was, but luckily Tiki saw the error right away. We drew the wrong end on our arrowhead B, so let's take these ones off here.
Oh, there it is.
That B should have gone. It should have gone in minus 1 up to, no, the B was right.
Oh, Tiki, you were wrong.
Tiki, what were you thinking? Okay, we got it figured out now. Sebastian figured it out for us. He noticed that we were drawing the resultant from before instead of A. So if A normally went 2 to the right and down 1, the opposite of A would be going to the left and up 1. And sure enough, now our resultant is 3 to the left and 4 up. And there we go. Yeah. Thanks. All right. And then C. We're going to double B and double A. So writing this out, we would have 2 times b. And this is very much like grade 9 algebra. And we're going to double A. Can you see that you're going to forget to underline them sometimes? You're just going to go and be like, oh, I forgot to underline them. Yes, there's notation stuff here. You have to do it throughout.
Oh my goodness.
And then combine your like terms. So you're going to have 2i plus 4j. And so what would this look like? Do I have enough grid paper here to work? I'm going to start here. And if B goes from here to here, 2 B's would do that twice. You just underline the letter. 2 B's would go twice that way. And if A, and this time we'll draw A properly, thanks Sebastian. A goes down like that, then 2 of them would go down twice. And our resultant is right here, going 2 over and 4 up, which matches the math. The good thing is the mic doesn't pick up too far away. So when Tiki said that, oh, I made a mistake, that didn't come up on the...
Throwing her under the bus.
But maybe we can put an 18 plus content rating on this video. And then if you go to 3 dimensions, we have an I, a j, and a k. The k is the 3rd dimension. It would be like a z. You just add them up. So this is another way, instead of writing the i's, the j's, and the k's. This is writing it. The first one is like your x, y, z, or I, j, k. And in these ones, I like it when it's written this way, because if I write out p like that, and I write out q right beside it, (3 plus -2 is 1. -1 plus 0. -1 and 4 plus 3, 7. And if you want to try to confuse yourself, try to draw that in 3 dimensions to show that result.
Maybe not.
No thanks?
Okay.
You're okay? Good.
I just
And for the second one, 3, -1, 4, minus, and the half,
What?
half of q,
You can't just throw that in.
that half can go to each one of those. Because when you cut a vector in half, you cut each component in half. So you'd have 3, -1, 4, minus -1, 0, 3 over 2. 3 minus the -1 is 4. No underlining, unless you wanted to rewrite what you started with, like p minus half q equals. But in this case, we're showing that it's equal to it as we go along. -1 minus 0 is still -1. And 4 minus 3 1/2
5 over 2.
is 5 over 2 if you get a common denominator.
got that one.
And add or subtract them.
I got it.
So try this one on your own. We'll put up the answers in a bit. I'll come around and help. Oh, hey, let's see how you did.
Blair wants to lie.
Oh, there's a new seating plan, Blair. All right, there's a new seating plan right behind Alexa. Okay, so in this case, because I don't like writing the I's, the J's, and the K's all the time, and I want to go from A to C, first of all, A goes to B. That's what that looks like as a vector. And B goes to C would look like this. So we want to find A to C, which we could do by just adding A to B plus B to C. And the way I'm going to write that is instead of writing A to B as 4i plus 7j minus 3, I'm going to write it as 4, 7, minus 3. These column vectors are a lot nicer because you don't have to write the i's, the j's, and the k's, and you don't have to underline things. And then we're going to add minus 1, 2, and minus 5. And we're going to get 3, 9, and minus 8, or 3i plus 9j minus 8k. And I might write my final answer in the same form that the question was, but for my work, I'll go to the column vectors.
Thank you.
You're welcome. Again, for a lot of these vector questions, you're going to want to draw a picture out first. Because in this one, we're given A to B, we're given A to C, and we want to find B to C. So here's A, here's B, here's C. What do we know? We know A to C, which is this vector with this arrow on it. We know A to B, which is this vector with this arrow on it. We want to find B to C here. So looking at how our arrowheads are placed, if we're going to want to add vectors together, that's only when the arrowhead and the tail of a vector are together. So one expression I could write from this is that A to B plus B to C is equal to A to C. So if I want to find B to C, it would equal A to C minus A to B. And now we can go and put things in. Where A to C was 1 and 5. And notice that there is, oh, wait a minute, there's no J. So that 5 was with the K. What am I going to put for the J? A 0. Minus, and A to B, negative 3 to negative 6. So we get 4, negative 2, 11. So the things that can get confusing here is just if you try to do it without the diagram, you're going to have a tough time making that expression. Just drawing a quick diagram, showing what do I know and putting the arrowheads on in the right direction, and then writing it out. Okay? Some people would say, if I started here and I wanted to get to here, because that's what BC is, how could I do that? Well, I would have to go backwards along this one first. So that would be negative A to B. You could write it as B to A, right? But we don't have a B to A up here. So we write it as negative A to B, and then we can add A to C. Now that's going to be exactly the same thing that we wrote down here in blue, but it's another way of using your diagram to start. Say I'm starting here and I want to end over here. And that is the end of adding and what we're going to stop at today, and then pick some random questions for review.